Hi guys, this tutorial answers the question, what's an isotope? Iso means the same in Greek, so isotopes are atoms of the same element that have different numbers of neutrons. That's the definition. Now, neutrons don't have a charge, so they don't add any charge to the atom, but they do add mass. And so this is why on the periodic table the masses of the different atoms are not whole numbers. Because if you think about it, way back when I taught you about the different subatomic particles, I pointed out that electrons we consider as having virtually no mass, so they're basically zero. And protons and neutrons we consider as each having a mass of 1 atomic mass unit. So in theory, the mass of an atom is just the number of protons plus the number of neutrons. So take, for example, the hydrogen atom. A hydrogen atom has typically in it 1 proton that attracts 1 electron. And there's a normal hydrogen atom. He's got no neutrons. That's the typical hydrogen atom. So the mass of that hydrogen atom, what we call the mass number, is 1. Because there's 1 proton and 1 neutron, so the total mass is 1. But there are some isotopes of hydrogen that have a neutron. So that would look like this. 1 proton, 1 neutron in the nucleus, still only 1 electron. So it's still a hydrogen atom because the definition of what atom you are is determined by how many protons you have. So since we still have 1 proton, we're still hydrogen. This hydrogen, though, has a little more mass. Its mass number is 2 because 1 plus 1 equals 2. And that's a pretty rare version of hydrogen. 99% of all the hydrogen in the world is this guy. Less than 1% is this guy. And there's an even more rare one that's less than 0.5% of the universe's hydrogen. Looks like this. He's got 1 proton and 2 neutrons. I apologize for how sloppy this is. So he has a mass number of 3. So on average, the mass of these 3 different versions of hydrogen, the 3 different isotopes, the average mass is 1.00, I think 7. I'm going to look on the periodic table right now. 1.00764. And that's atomic mass units that's in. How'd they get that number? Well, it's because 99 out of 100 of these atoms have a mass of 1. But then every once in a while, you get the random this guy or this guy, which brings the mass up just a little above 1. And this is true for the entire periodic table. All the atomic masses are not whole numbers because they're the average atomic mass of all the isotopes. And they're weighted, right? Because there's some isotopes are more common than others. So if you want to know the most common isotope of a particular element, you round the average atomic mass to the mass number. So for example, let's look at these 3 atoms and see what the most common isotope of each one is. If you look on the periodic table, sodium has an average atomic mass of 22.989, blah, blah, blah. A whole bunch of stuff there. So what that means is that some sodium atoms have a mass of 22, but most of them have a mass of 23. So on average, that brings the average to be 22.989, blah, blah, blah. So the most common isotope of sodium has the mass number 23. If you subtract the number of protons from that, which is 11, then that means the most common isotope of sodium has 12 neutrons. And there's another isotope that must have only 11, and that's why the one that has 11, which is very uncommon, brings the average mass down to 22.989. Chlorine, on the other hand, has an average mass of 35.453, which must mean that if we were to round that, that would round down to 35. And if we were to subtract the protons, of which there are 17 for chlorine, that would mean the most common isotope of chlorine has 18 neutrons. But there's also a version of chlorine that has how many neutrons? Well, there must be one that has 19, because if we had 19 neutrons, then we'd get a mass of 36, and 35.453 is like the average between 35 and 36, right? This chlorine isotopes, there's two versions of chlorine, and they're both almost equally abundant, right? If you had exactly half the chlorine in the world had 18, and the other half had 19 neutrons, then the average mass would come out to be 35.5. Because remember, you got to add in the protons, right? So 17 and 18 is 35, and 17 and 19 is 36, and 36 and 35, the average of them is 35.5. So the most common isotope of chlorine is chlorine that has 18 neutrons, the one that has the mass number 35, but there's an almost equally abundant version of chlorine out there that has a mass of 36 and has 19 neutrons. What about oxygen? Well, oxygen has a mass of 16.994, I believe, if I'm reading that correctly, or is it 15? Yeah, it's 15, my bad. Sorry. 15.994, which is almost 16, right? So most oxygen atoms have a mass of 16, and since there are 8 protons, that means most oxygen atoms have 8 neutrons. That's how we get that mass, right? But there must be a few oxygen atoms that don't have 8 neutrons. They only have 7, and they must be pretty rare, because if they weren't, then the mass would not average out to be so close to 16. So that's what an isotope is. So key things to remember. Isotopes are atoms of the same element that have varying numbers of neutrons. If you want to know the most common isotope, just round this number to the nearest whole number. And you can figure out how many neutrons are in that one by subtraction, right? 23 minus 11 protons gives me 12 neutrons. And that's it for isotopes. See you in class.